We are covering counting and probability basics for the AFOQT, specifically for the arithmetic reasoning and math knowledge subtests. The core challenge is determining whether a scenario requires a permutation or a combination. A permutation is an arrangement where order matters. Think of assigning specific, unique roles, like a pilot and a co-pilot from a group of candidates. The formula is n factorial divided by the quantity n minus r factorial. A combination, on the other hand, is a selection where order does not matter. Imagine forming a two-person study group. Who you pick first doesn't change the group's composition. The formula for combinations is n factorial divided by the product of r factorial and the quantity n minus r factorial. A major exam trap is using the wrong formula. The AFOQT will present word problems designed to confuse the two. For example, a question might ask, from 5 qualified pilots, how many ways can a flight commander and a deputy commander be selected? Because the positions are distinct, order matters, and this is a permutation. Here, n is 5 and r is 2. The calculation is 5 factorial divided by 5 minus 2 factorial, which simplifies to 5 times 4, equaling 20. If the question asked, how many two-pilot crews can be formed, order wouldn't matter, making it a combination. The calculation would be 5 factorial divided by the product of 2 factorial and 3 factorial, resulting in 10 possible crews. Notice how the permutation yields a higher number, which is always the case. The AFOQT keeps the numbers small, usually under 6 items, so you must be comfortable calculating factorials like 5 factorial, which is 5 times 4 times 3 times 2 times 1, or 120, by hand. A simple mnemonic to remember the difference is, permutation means position matters, while combination means the committee doesn't care about the order. Now let's shift to probability. The basic formula is the number of favorable outcomes divided by the total number of possible outcomes. For instance, if a bag contains 3 red and 7 blue marbles, the probability of drawing a red marble is 3 out of 10. The AFOQT tests multiple events using keywords. And means you multiply the probabilities of the individual events. For example, the probability of drawing a red marble, replacing it, and then drawing a blue marble is 3 over 10 times 7 over 10, which equals 21 over 100. A common trap is the without replacement scenario. If you don't replace the first marble, the total number of outcomes for the second draw decreases. In our example, the probability would become 3 over 10 times 7 over 9. The keyword or means you add the probabilities, but only for mutually exclusive events, meaning they can't happen at the same time. For example, the probability of drawing a red or a blue marble is 3 over 10 plus 7 over 10, which equals 1. If events can overlap, you must subtract the overlap. For instance, in a standard 52-card deck, the probability of drawing a king or a spade is the probability of a king plus the probability of a spade minus the probability of the king of spades. This would be 4 over 52 plus 13 over 52 minus 1 over 52. Mastering the distinction between permutations and combinations and knowing when to multiply versus add probabilities is critical for maximizing your score on the quantitative sections of the AFOQT. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.